Okay, so let me just quickly do this one. This is dp over, like, if I multiply dt, this would be 2p minus 2p times t dt. And then if you just factor out 2p, 1 minus t dt. And then if you divide p, for example, if you divide only p, you will be left with this one. And then if you integrate, this is natural log of p, and this is 2 t minus t squared divided by 2 plus c. Okay, so you just integrate, and then, like, if you want, you can write the explicit solution here. If not, then you can just find the value of constant first, then write the explicit solution. It's all okay. So p of 0 is equal to 5. Okay, let's name this star first. This means what? This means that for t is equal to 0, the value of p is equal to 5. You substitute this in the problem in a star equation. Left hand side would be natural log of 5. Right hand side would be 2, 0 minus 0 square divided by 2 plus c. Okay, and yeah, so this will give the value of c to be natural log of 5. So you substitute back in this problem. This will give you 2 t minus t square over 2 plus natural log of 5. If you take exponential on both sides, the left hand side would be p, right hand side would be e to the 2 times t minus t square divided by 2 times e to the natural log of 5. So the second term e and natural log can be like cancelled. You'll be left with 5. So this is 5 times e 2 to the t minus e to the 2 t minus t squared divided by 2. So this is the solution for that problem. Okay, and you can still verify if you put t is equal to 0, the value of p will be 5. And if you differentiate and substitute in the actual differential equation, you will get the left hand side would be equal to the right hand side. Okay, so let me help you with only separating the variables, and then you will be integrating. And once we are done with this problem, we are done with this section. And on Monday, the first thing that we'll be doing will be a small lecture activity on this section only, separation of variables. So x times x plus 1 du over dx is equal to u square. The variables are u and x. Let's separate the variables. So multiplying dx first on both sides. Du is equal to u square dx. And maybe dividing x times x plus 1 on both sides. X times x plus 1, x times x plus 1. I'm also dividing u square. We can do everything in a single step as well. So this cancels this one. The left hand side would be du over u square, and the right hand side would be dx over x times x plus 1. And the next step, once you separate the variables, you know that, okay, the next step is you integrate. So I help you with separating the variables. Now simply integrate the left hand side, integrate the right hand side, and you're done. Any hint on the right-hand side? What does it mean? What does it mean? Ah, yeah, yeah. See, like how boring and how miserable the analysis. You brought in a witness how bad the class is. And then that example. You're going through too much. So this is like worse and stuff, you. Okay, so the problem is right hand side. What if I remove x plus 1? What would the integral be? Yeah, integral dx over x, which is natural log of x, for example. So if I remove this guy, the integral is really simple. And if I remove x, what is the integral of dx over x plus 1? Yeah. So, like we are thinking in this way that if you remove one of these terms, the integral is really simple. So the idea is, can we like separate these terms in such a way that we can integrate these? And for that, we have a method and we call that You both are done, I think. Are you done with this? You're not done, but you know. I think that was very last section in integration. I think. Like not the last section, the middle section, but from techniques of integration, it was the last technique that we learned. Yeah. What is that? You know the name, partial fractions. Okay. Yeah, so it is like partial fractions. You decompose this fraction into two fractions, and then you integrate every one of the terms. So 1 over x times x plus 1, if you are thinking this thing in this way, like you can write the product directly and integrate, like you can do this thing. Mathematically, left hand side is equal to right hand side. But integral of the product is not same as you integrate the first term and then times you integrate the second term. This is wrong. Okay? Because you know that the integral of the product, for that we have to apply the formula of integration by parts. So this is not the valid way. We have to do partial fractions, which is this thing. We have to find a constant a whose denominator is x, and we have to find another constant b whose denominator is x plus 1. So you find the values of a and b. So the left hand side is equal to right hand side. So the integral of left hand side is the integral of the first term plus the integral of the second term. That's it. So as I mentioned, like here we need to apply the techniques of integration. Maybe there can be even a crazier problem where you need to apply another type of integration technique. But this is all about you separate the variables and you integrate, you got the solution. So maybe you know these things, but I think the values of those constants will be, you got those values? What are those? -1. Yeah. For some problems, there are some short tricks that also work, but those tricks do not work for all the problems. But I would also always prefer to apply those tricks before moving to like do this lengthy stuff and find the values of a and b by using some classical methods that we have done before. For example, this problem is this. I'm trying a method, maybe it might work, might not, I don't know. So what should I do? Maybe I can add and subtract x in the numerator. Can I do this thing? Because if you cancel x with x, you will be left with 1, which is reasonable because it is the actual value is 1. Okay. So I'm just rewriting everything in this way. I'm just like writing x plus 1 first and then minus x. And then what I can do is I can split these quantities and divide both by x plus 1. This is pretty valid point mathematically. The first term is x plus 1 and the second term is negative x. I'm dividing both with the same denominator, x times x plus 1, x times x plus 1. This is pretty valid. Nothing wrong with this mathematically. You can see the first one is, like you can cancel x plus 1. Why I added and subtracted x? Because I wanted to create a term which looks like one of the terms in the denominator so that I can cancel out that term. And once I did this thing, I got 1 over x. And I can cancel x here, and I got negative 1 over x plus 1. This is what those coefficients should be. The value of a should be 1 and the value of b should be negative 1. You can do this thing if you want, but this does not work always. Yeah.
What if to x plus 1 plus x? Wouldn't that also cancel out x on the right side and leave you with plus 1 over x plus 1? So you'd have like 1 over x plus 1 over x plus 1.
Y plus?
Yeah, like why wouldn't we just add x instead of subtracting x?
You mean this one?
Yeah.
If you add 2x, it means you are adding something by your own. I'm just adding something and then subtracting so that everything is balanced. Yeah, you can add and subtract something at the same time. If you want to make sense of like keeping the things mathematically true, you can add and subtract the same quantity at the same time. Yeah. What should I say? Like you're not going to give any extra thing there. You are just adding something and then subtracting. Why are you doing this thing? Just to simplify the things in the right way. If you only add the things like you add x and then you add x again, so this is not mathematically valid thing. It means that if you got your answer to be 5 from some solution, but the actual answer is 15, and then you are saying, okay, let's add 10. You can't do this thing by your own. If you are adding 10, you have to subtract 10 at the same point. Yeah, so you can do this thing. This is pretty valid. Does not work for all the problems. So you have to find the values of a and b as we did while we were doing the method of partial fractions. So integral of left hand side is negative 1 over u. Integral of right hand side is these two partial fractions dx. And if you integrate, you will get natural log of x minus natural log of x plus 1. It is, I think, mandatory to put absolute value here because the value of x can be anything we don't know. It's independent variable plus constant of integration. Now it's time to introduce the initial condition, which is u of 1 is equal to 1. It means at x is equal to 1, the value of u is equal to 1. So if I substitute this in this solution, which is a general solution, I'll get negative 1 over 1, natural log of 1 minus natural log of 2 plus c. So this is negative 1, and you know natural log of 1 is 0 minus natural log of 2. I don't need to put absolute value because 2 is a positive number. So I don't need to. So the value of c is natural log of 2 minus 1. Okay, if you add natural log of 2 on both sides. You substitute this back in a star, negative 1 over u is natural log of, I can combine these and rewrite these in this way, if you agree. And c is natural log of 2 minus 1. Maybe I shouldn't do this thing quickly. Let me tell you something else, then do this thing. What should I do? Let me take this down. I'm multiplying negative 1 on both sides. This will give me 1 over u is equal to natural log of x plus 1, which will be positive, minus natural log of x minus natural log of 2 plus 1. And then on right hand side, I can do one thing, and that is like if you have like these, like you can combine these all log terms. The terms with negative coefficient will be in the denominator, and the terms with positive coefficient will be in the numerator. And you can combine these all the log terms together, plus 1. And this is a solution. If you want to write the explicit solution, that will look like this one. 1 over everything. Because I'm just flipping everything, 1 over natural log of absolute value of x plus 1 divided by 2x plus 1. That is the explicit solution, but if you want, you can leave the solution at this point as well. Because this is the point after finding the value of c, you put that back into the star solution and you get this explicit solution or the implicit solution for the problem. Okay, any questions?